Let's talk about grounding and bonding in a solar system real quick. There is only one equipment grounding conductor, an EGC, coming in from the PV array, and presumably there's 4 inverters. And here we have pictured one of the inverters, and that wire is somehow fished in through to the AC side, and their concern is that this DC ground is getting landed on the AC side of only one inverter. We're not relying on this flex as an EGC. There is a green wire going through this conduit and landing on the AC side as well. And that is true for all, presumably, again, 4 inverters. So his concern is that this wire should have been landed on the DC bus bar, which is right here under our PV circuit conductors. And it should have been landed on the DC side for each inverter, not just one. If you understand how equipment grounding works, you're just trying to attach all of the metal pieces together, so that if anything live touches anything metal, you have a clear fault path to be able to reference that and or potentially trip a breaker or serve for the grounding fault detection. 250.4 general requirements for grounding and bonding. We're going to go down here to ungrounded systems. So 250.4b, and what's applicable here is sections 2 and 3. They read very similarly, so I'm just going to read this one. This one's about electrical equipment, and this one is bonding of electrically conductive materials and other equipment. Electrically conductive materials that are likely to become energized shall be connected together and to the supply system grounded equipment in a manner that creates a low impedance path for ground fault current that is capable of carrying the maximum fault current likely to be imposed on it. Which this does accomplish that. You have the DC ground coming in here bonding to the inverter, and in the inverter it bonds to the AC system, and the AC system goes to all of the other inverters as well. So all of these inverters are bonded together in this equipment grounding structure. The retort that I got was, no, you have to follow the manufacturer's instructions. Connect each equipment grounding conductor of the PV array to an equipment grounding terminal. Does the AC equipment grounding terminal not count as an equipment grounding terminal? Sure, if we're being pedantic, it points to this bus bar on the DC side. But this, in my opinion, is the lamest way to try to win this argument. And it also completely misunderstands how equipment grounding is supposed to work. If you are saying that connecting to the AC equipment grounding conductor is not electrically the same as connecting to the DC equipment grounding terminal, then you have a problem. You need to now start installing your inverters with bonding jumpers between your AC equipment grounding terminal and your DC equipment grounding terminal, because all that stuff needs to be bonded together as per the code.